This video is going to cover the calculations required to get your minor diameter or your thread relief groove diameter. I want to use 3/4 10 because that is not a size that you have on your assignment. Now the 3/4, that is going to be the major diameter. I'm going to go ahead and write that as a decimal. Now, if you're not sure on how to convert a fraction into a decimal, it is actually quite simple. Just look at the fraction and enter it into the calculator just as you see it, meaning 3 divided by 4 equals 0.75. Now, the next column that we're going to address will cover our 10 in the 3/4 10. Now, this would be an NC thread, meaning national course. So if all I had provided was the diameter and NC, I would know that when I looked at the thread specification charts, I would be looking for 3/4 diameter and then the NC designation, and next to that I would see 10 threads per inch. Now, I just wrote TPI as an abbreviation for threads per inch, but in that column there, it's just 10. Next, we're going to look at the thread pitch. The thread pitch is usually called out from the very, very top point of one thread that is the distance to the next thread over. The formula for calculating the pitch is very simple. It is the thread's TPI divided by 1. The 1 represents 1 inch of distance. It has nothing to do with diameter. So please don't confuse that. It would be TPI divided by 1. So 10 divided by 1 is pretty easy math. It is just 0.100. Now, moving down further, you see the depth. The depth of the thread that we're calculating right now is on 1/2 of the part. You have to remember that. It'll come into play on the next equation. But all we do is we simply take the pitch, the 0.1 that may still be in your calculator, and you multiply that by 0.866. That's a pretty easy calculation when you're talking about 10 threads per inch. So the answer is 0.086. Now, to calculate the minor diameter of the thread, that's the whole reason we're doing all this, we have to take the depth times 2, because we're looking at the top portion of the thread and the bottom portion, so we have to double the depth because there's a thread on both sides of the part. So you multiply that by 2. That's what we see here. Depth times 2 subtracted from the nominal major diameter. So it would be 0.086 times 2, hit equals, and then hit subtract from 0.75, and then that will give you the minor diameter. Let me go ahead and do this really quick on my calculator because I didn't fully prepare this one. But it's very simple. So my 0.086 times 2, that's the 0.172, minus 0.75 equals 0.578. Now, that is our root diameter for the thread, or our thread relief groove diameter. This quick video is going to go over how to grind your thread relief grooving tool. So you're going to get a piece of 5/16 inch wide high-speed steel tooling. That's what that represents there. And that's the 5/16. Now, you'll notice on your print that you make a groove that's 3/16 of an inch wide, and then you make some grooves that are 1/8 inch wide. We're going to start with the 3/16 wide grooving tool because if we make a mistake, it can become the 1/8 inch wide tool. Now, if this is 5/16 and I'm going to grind a 3/16 wide grooving radius on this end of the tool, I would need to subtract 3/16 from my 5/16, and that would give me 1/8 of an inch that I'm going to be grinding off the part. So you'll put bluing on this surface, and then you'll set the part on the height gauge, and you'll come up 1/8 of an inch, and you'll scribe a line. It'll look something like this. And just scribe it back like 1 inch or so. You're not going to grind the tool back that far, but you'd be better off to have a really long line than a short line, because as you start to remove the material on this side, that would be the 1/8 inch side, it's going to discolor and burn away some of the layout dye. So more is better when you're scribing your line. But out at the grinder, you will be removing the material off the right side of the tool blank, and that's because our shoulders are on the left on this project, so we want to have one side of your tool be completely straight, and then the other side where there's not going to be any shoulders, that'll be where we have a shoulder step. You need to grind back down the tool, I would say about, well, 5/16 or maybe 3/8 of an inch would be plenty adequate. Don't try to grind all the way down the tool, let's say 1 inch. You're just wasting your time and there's no benefit. So the first thing is we're going to get rid of the material that I kind of erased a second ago, and we're going to do that until we achieve a nice width that is as close as we can get it to 3/16 of an inch wide, and then we're going to start to form the radius. And much like right now when I'm drawing on the board, it's not going to be truly perfect, but you're going to do it to the best of your ability. You're going to use radius gauges to inspect it as you go, and when you get it as good as you can, that's what we're going to go with, okay?